Okay, so today we're going to look at section 3.4, polynomial functions, graphs, applications, and models. So we start with a polynomial function as a function of the form f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n sub 1, n minus 1, plus all the way to a to the 1x plus a to the 0. So we have many characteristics of polynomial functions that help with identifying the graph of that function. First up is the degree of the polynomial is the highest power of x. In the case of our generic term here, that would be n. The leading coefficient is the number in front of the x with the highest power. In that case, it would be a sub n. In general, the graph of a polynomial function of a degree n has at most n x-intercepts or zeros. So at most n, could be less. Turning point of a polynomial is a point at which the graph changes direction from increasing to decreasing or decreasing to increasing. A polynomial of degree n has at most n minus 1 turning points. So this will help us figure out graphs. So we're going to start out, determine the leading term, degree, leading coefficient, and the maximum number of x-intercepts and turning points. So the leading term is the highest power is 10. So the leading term is negative 4.7x to the 10th. That's our leading term. Our degree, well, that's just the power of the leading term, which is 10. Our leading coefficient, well, that's just negative 4.7. Maximum number of x-intercepts, well, that's the degree, right? N, which is 10. And max turns is n minus 1, which would be 9. Okay, so let's look at another one here. Keep in mind, this is our leading term. It has the highest power. That's 2x to the 14th. The degree of this polynomial is 14. The leading coefficient is 2. Maximum turn, max x-intercept, sorry, is 14, and the maximum turns is 14 minus 1, or 13. We can also find x and y intercepts of polynomial functions. If you remember, we find the x-intercept by letting y equal 0, and the y-intercept by letting x equal 0. So let's do this. So we're going to find the x and y intercepts. So to find the x-intercept, we let y equal 0, which means this is equal to 0. And the rest of this just comes down. So what this means is x minus 6 equals 0, or x squared minus 9 equals 0, or x plus 4 equals 0. So here we have x equals 6, x squared equals 9, so x equals plus or minus 3, and x equals negative 4. Now, if you look here, if we multiply all this out, we have 1, 3, a 5th degree. We would have a 5th degree polynomial. So we're okay. We have 4 x-intercepts. We could have a 5th one, but we do not. And now we're going to find the y-intercepts by setting x equals 0. I have f of 0 equal to 2 times 0 minus 6 times 0 squared minus 9 times 0 plus 4 squared. So this is 2 times negative 6, negative 12. This is simply negative 9, and this is 16. Now I have negative 12 times 9 times 16. And I get 1,728. That's pretty far up there. So these are my x-intercepts, and this is my y-intercept. Okay, finding the x-intercepts and the y-intercepts again. So to find the x-intercept or y-intercept, we let x equal 0. I find f of 0, which is 0 plus 2 times 0 minus 15 times 0, which is 0. So looking at 0, 0 here. Coincidentally, so I only have one x-intercept or y-intercept. Now, to find the x-intercept, we can factor this. I can factor out an x squared and get x squared plus 2x minus 15, which can be factored as x minus 3 times x plus 5, which means that which tells me that x squared equals 0, x equals 0, x minus 3 equals 0, x equals 3, and x plus 5 equals 0, x equals negative 5. So I have 3 x-intercepts. And here's one of them. It's also the y-intercept. Okay, so let's look at another one here. Again, finding y-intercept, we let x equals 0. We get negative 3 times 0 plus 9 times 0 plus 3 times 0 minus 9, and we get negative 9. So we have 0, negative 9. That is my y-intercept. Now, we can factor this by something called grouping. So let's look at this. Negative 3x to the third plus 9x squared plus 3x minus 9. So if I take these two terms and take negative 3x squared out of them, I get x minus 3. Here, if I take 3 out of these two terms, plus 3 times x minus 3. So that means I have negative 3 x squared plus 3 times x minus 3. And I want to set this equal to 0. That means one of my possible answers is x equals 3. So we'd have the point 3, 0. Now I'm left with this negative 3x squared plus 3 equals 0. Looking at this part here, if I divide everything by negative 3, I get x squared minus 1 equals 0. If I add 1 to both sides, get x squared equals 1, so x equals plus or minus 1. So I have 1, 0, and negative 1, 0. We had a third degree polynomial. We have 3 places where it crosses the x-axis. Next thing we're going to look at is the end behavior. As the x-coordinate increases or decreases without bound, the graph of the polynomial function eventually rises or falls without bound. In other words, it may go like this, it may go like that. That's decreasing without bound. It may go like this, it may go like that. That's increasing without bound. And it could either increase or decrease. That's what we're talking about. The end behavior of the graph depends on the degree n and the leading coefficient a sub n of a polynomial function. We can use the leading term of the polynomial and determine what happens to the y values or function values when x approaches negative infinity and when x approaches infinity. So first, let's look at the case where n is even. So when n is even, we're basically going to have something that resembles a parabola. Something like this. And it may do all kinds of weird stuff in here. So when n is even, we might get this end behavior. And this is when a sub n is positive. Or you might get this end behavior. And something going on in here when a sub n is negative. So what is the end behavior of the graph? Well, here we have n is equal to 6. And here we have a sub n is negative 7. So we're looking for this and this. As x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches negative infinity. Okay, now, if n is odd, we have something that looks something like this, or like this. This is if a sub n is positive, and this is if a sub n is negative. So looking here, I've got this. This is my leading term, even though it's not first. N is 5. And a sub n, we have n equals 5. A sub n is negative 9. That means I'm looking at this. As it approaches negative infinity, as x approaches negative infinity, as x approaches negative infinity, y approaches infinity. And as x approaches positive infinity, y approaches negative infinity. Okay, so here, we look at this. We don't have to look at this. We just need the leading term. So I have negative 3 times x squared. Well, actually, that's going to be negative 3 times x squared. And then after we square that, we're going to have this. So it's going to give us negative 2x cubed. Or we could let's just multiply it out. So this becomes negative 3 times x squared minus 8x plus 16 times negative 2x plus 5. Okay. So really all we need is the highest degree term which is going to be the third degree term that we get here. So we can stop at this because none of the other multiplications are going to give us anything higher than x to the third or x to the third. So this is the leading term, and we take that and we get 6x to the third. So n is 3, and a sub n is positive 6. So we're looking at this general shape. So we're looking at, as x approaches infinity, y approaches infinity. And as x approaches negative infinity, y approaches negative infinity. That brings us back to multiplicity in the behavior of the graph. The polynomial contains a factor of the form x minus h to the p. The behavior near the x-intercept h is determined by the power p. We say that x equals h is a zero of multiplicity p. The graph of a polynomial function will touch the x-axis and turn around at zeros with even multiplicities. And the graph of a polynomial will cross the x-axis at zeros with odd multiplicities. The sum of the multiplicities is the degree of the polynomial. Recall that a polynomial of degree p will have at most p minus 1 turning points. This will be helpful when graphing polynomials. So, find the zeros and give the multiplicity of each. State whether it touches or crosses. Cross at odd, turn around at even. So this first we have x equals 0. The multiplicity is 2. And that's even. So when we have an even multiplicity, it touches. Here we have 2x plus 3 equals 0. 2x equals negative 3. X equals negative 3 halves. We have x equals negative 3 halves, which has a multiplicity of 5. And since 5 is odd, it crosses. And lastly, we have x minus 4, which is x equals 4, with a multiplicity of 2. And since it's even, it touches. Okay. So on this next one, we need to break this down again. This becomes x minus 5 times x minus 5, which is x minus 5 squared. So I have my first one here. 3x plus 2 equals 0 to find the 0. 3x equals negative 2. X equals negative 2 thirds. So that's my first 0. X equals negative 2 thirds. Has a multiplicity of 4. And since it's even, it touches. My next one here, x minus 5, that means x equals 5. It has a multiplicity of 2, which also means it touches. So find the y-intercept, x-intercept in behavior and graph the function. So we're looking for y-intercept, which means let x equal 0. So f of 0 equals 0 minus 1 times 0 plus 2 squared is negative 1 times 4 is negative 4. So at x equals 0, we have it right there. 0, negative 4. Okay, now to find our x-intercepts, well, we set this equals 0 and we get x equals 1. And set the second one equals 0. Get x equals -2. Okay. So we're looking at 1, 0, -2, 0. So we have our y-intercept, our x-intercept, our multiplicity. This has a multiplicity of 2. Okay. So multiplicity of 2, that's even. Let's go back and check. Even means it touches. Okay, so I have multiplicity. What happens, the other one, it crosses. And the end behavior. Okay, so this is a x times x squared, so it's x cubed, and it's 1, so it's positive. So it touches here. Positive odd. Positive odd means down this way and up this way. So we're looking for crosses here, touches here, like so. Now I'm sure this will be more curved, but that's the basic general shape from this information. Okay, so same thing. First thing I can do is factor out a negative x and get negative x times x squared minus x minus 6. So that's negative x times x minus 3 times x plus 2. Now going back to my original, if I plug in f of 0, I get 0, 0, 0. So my y-intercept is 0, 0. My x-intercepts are 0, 3, and -2. 0, 3, and -2. I have a cubic function. My first term is negative. So this one is up, down, with some funky stuff in the middle. So it's probably going to go something like, and they all have multiplicities of 1. So I'm crossing. So I'm crossing. So I need to go down, go up, probably something like that. The general idea. Okay, here. First we find f of 0. 0 plus 1 to the 4th times 0 plus 3 squared. So this is 1 times 9, which is 9. So when x is 0, y is 9 up here. 0, 9. Our zeros, we have x plus 1 equals 0, x equals -1, and our multiplicity is 4, which means touches, correct? Even is touch. Yes, even touches. Okay. And then my other 0 is x plus 3 equals 0, which is x equals -3 with a multiplicity of 2, so it touches as well. So I have -3 here. I have 2 here. And it touches at both of them. So let's see. I'm looking at my leading term. It's going to be x to the 4th times x squared, x to the 6th, 1. So I'm looking at this. So it touches and goes up forever, comes up here, comes back down, touches and goes up forever. Kind of like a W. Okay, now we're going to use the graph, if I can find the graph. Okay. So here we have zeros at x equals -1, x equals 2. This is a touch, this is a cross. And I have a y-intercept. At 0, 2. So let's try to put this together. And if I need another point here, I have 1, 4. Okay, so this is touching. And if you look, I've got them going in opposite directions, up and down. So I'm looking for an odd degree. Since it has two zeros, it has to have 2 or more. The degree has to be greater than 2. So let's see what we can come out with. So I have x equals -1, which is a cross. So we'll have x plus 1. Then I have x equals 2. Oops. Let's translate the x minus 2. And we need that to be even. So squared. So now we have a third degree term. So we have some value here, a, so that f of 0 equals 2. So a times 1 times -2 squared. A times 4, a equals 1/2. So let's see if that works. So what is f of 1? F of 1 equals 1/2 times 1 plus 1 times 1 minus 2 squared. Equals 1/2 of 2 times 1, and that does not work. One moment. Okay, so we know that this has to be to an even power, and this has to be to an odd. So let's raise this to the third power and see what happens here. So same, this works out the same as far as here. It is still, if we find f of 0, we still have 1 times -2 squared, 2, so a is 1/2. Now let's try to find, well, we're going to say that f of x equals 1/2 x plus 1 cubed x minus 2 squared. That's what we're saying it is. So if I let x equal 1, I get 1/2 of 1 plus 1 cubed times 1 minus 2 squared, which is 1/2 of 2 cubed times -1 squared, which is 1/2 of 8 times 1, which is 4. So that is our correct formula, our correct equation. Except it should be negative. That doesn't make any sense though. Let's look at this one. Again, we have a 0 at -2 and 3. Crosses here, touches here. Again, opposite directions, so we're looking at an odd numbered function. So let's see, we have x minus, or x plus 2 times x minus 3. Again, this is even, this is odd. So we'll square this. And we have this point here to help us out. F of x equals some value. Okay. So f of 0 equal to a times 0 plus 2 squared times 0 minus 3. A times 4 times -3. A times -12. We're looking for 3, so a is 1/4. So now I would have f of x equals 1/4 x plus 2 squared x minus 3. So let's go back up to this one, because there's something going on here. This should be, a should be negative for some reason, and it's not turning out to be so. So let's see if we got everything right. Okay. We know we have an odd degree. And going back up here. Now we discussed this. There's it. We're looking for up to infinity, up to infinity, down to infinity, which means it should be negative, the leading degree. We have a 0 at, no, 0 at x equals -1. That gives me x plus 1. And I have a 0 at x equals 2. That gives me x minus 2. Did I get that backwards? Maybe that's it. That is what we did backwards. Gotta be careful with this stuff. Or did I? Even degree touch. Yeah, even degree touches. So this has an even degree, and this has an odd degree. So this touches and this crosses. And that explains where my issue is. So let's go back to this. This is going to go away. See what happens here. So I'm going to go back to a simple third degree. I'll square this. And let's go, we have a times 1 squared times negative 2 equals 2. A times negative 2 equals 2. So a equals negative 1. That makes the math a little easier. So now let's see if this 0.14 works. So we're looking at f of x equals the negative of x plus 1 squared times x minus 2. So if I let x equal 1, I find f of 1 equals the negative of 1 plus 1 squared times 1 minus 2. So I have negative of 2 squared, which is 4, and 1 minus 2, negative 1. So I get negative 4 times negative 1, 4, which checks. So there it is. I thought that was a little more difficult than need be. So that is it. All I can say is be careful, take your time, and you should be able to get through this stuff. Have a good day, and I will see you next time.